When we speak about Lie groups, then our group is such an analytic manifold. So what does that do for us? Consider some chart, U phi, and then some group elements, say G and H, in this U. Now this G is mapped somewhere in Rn. It's mapped to a point, say with coordinates x1 to xn. So we can think of the group elements as parametrized by these coordinates x1 to xn. Let's say the H is mapped to y1 to yn in Rn. And now we say that this Lie group is an analytic manifold, and, for example, the map that takes G and H to the product of G and H, this is an analytic map. So this means that phi of GH, it also has some coordinates. It's also mapped somewhere in Rn. So that's, let's say, just to keep it simple, let's assume that GH is also in U here. Otherwise, we would need some transition functions here like these, but that doesn't really add anything. So these coordinates now are analytic functions of the axis, the x's and the y's. So that's what it means that this map is analytic. It means that these functions here are analytic functions of the x's and y's. Oh, and I see here that I wrote GH instead of G circ H. I don't need a symbol for the group operation here. And then, of course, we also demand that the map that takes G to its inverse, and the inverse also has some coordinates in Rn, and these are also analytic functions of these x's here.